Welcome to myprojectbazaar.com. Our project title is A Collaborative Approach for Monitoring Nodes Behavior During Spectrum Sensing to Mitigate Multiple Attacks in Cognitive Radio Networks. Abstract. In this process, we propose a novel spectrum-aware anypath routing protocol for multi-hop CRNs. We use a recently proposed network architecture for cognitive radio networks called Cognitive Capacity Harvesting Networks. Cognitive capacity harvesting consists of a secondary service provider, cognitive base stations, cognitive radio routers, and secondary users. The SSP is the operator and manager of CCH, which harvests spectrum resources and allocates it to the network. The CR routers are equipped with cognitive radios, which perform spectrum sensing, collect demand from SUs, and transmit their data around over available licensed spectrum. Let us see the flow of our project. This is our flow diagram for our cognitive radio network. First, we have to form our network with the network parameters such as radio channels and the antenna. And for the layer selection, that is the physical layer, and the energy model updations. First, we have to set the sensor nodes and the cognitive radio network and cognitive radio nodes. So first, in that from that network, we have to form the cluster. If the CR moves, means it will be update the cluster. So meanwhile, we have to identify the energy using the 4 parameters like transmission power, reception power, idle power, and sense power. So from that energy consumption, we have to do the successful transmission from the source to destination via the cognitive routers. We have to analyze our performance using the graph which analyze the performance between the existing and the proposed systems. Let us see the output of our project. For running our NS2 process, we have to switch on VMware workstation. So our process is run on command prompt only. So I am going to the command prompt and change directory to our code folder. cd space code, and this is the syntax for running our main file, which is a .tcl extension. So I am giving main.tcl. Now it will be create the security mechanisms for encryption standards. We use 32-bit encryption standard which protect all the nodes. Our process have 104 number of nodes. So our process is a cognitive radio network with service providers. This is the output window called a network animator window, which is in .nam extension. So when we click on this play forward, means it will be start to work. So our network is a large number of nodes with cognitive radio networks. So now I am giving the speed as 120 milliseconds. So this is our network with RSS key is generated. So now the primary and secondary user are formed. The magenta color shows the primary user, and none of others are denoted as secondary users. So that nodes, that is node number 2, 3, 4 and 1 are denoted as the service provider for all the primary user and secondary users. So now the primary users are set, and they want to send the message to the destination. For that, they send the data communication with the service provider. So now the data is transferred from the source node, which is denoted as 86, to the destination node, service provider. So it will send the information parallelly. So now the attacker is defined. So this red color node 13 is defined as attacker, and it will drop the packets which is sent by the source. So this packet wrapping ratio is denoted here, and it will drop the packets 230 bytes. So now parallelly the third network will send the information, and now the cognitive radio network obtain that attacker, and it will find the attacker, and it will sends the attacker information. Now the service providers are moved from one destination to other. If any service provider move means they have to adopt that position which is formed in cluster. So this is for running our simulation file in terminal. Now I am going to run our graph. So for running our graph we need xgraph. For that we have to code our script in awk script. So I am going to run xgraph space delay.xg for running our delay graph. So this is our delay graph, which is only given in the proposed system, denoted by out.tr. So next graph is packet delivery ratio graph, PDR. So this is our packet delivery ratio graph, and our another graph is THR graph, that is throughput. The number of packets sent at a time is denoted here. This 750 is Mbps, so 750 number of packets are sent to the destination. So final graph is energy.xg. For that we have to achieve less consumption energy than the existing system. Thank you for watching.